Hello, guys, and we are here with you as promised. So, let me introduce first of all. My name is Utkarsh Gupta. You all might be knowing me. I am currently an instructor at Sailor, and I was software engineer at Google before this. And today with us we have Bhavya, who is an ICPC World Finalist this year, and he will be conducting a live mock interview of Bhavya. Before that, let's Bhavya, please introduce yourself first.
So, hi everyone. I am Bhavy Jain. I am a undergraduate of IIT BHU Computer Science and Engineering. I interned at Microsoft and I'll soon be joining Microsoft Redmond as a full-time employee. Also, I qualified for ICPC World Finals this year.
Nice, congratulations.
Thank you.
But I guess because of COVID, we are like ICPC World Final is postponed for next year, right?
Yeah, so it will occur around the same date in 2021,
Nice.
21st, 20 to 26 June.
All the best,
Thank
and
you.
it's really proud to see someone like this. All right, so let's directly start with the live mock interview, and after the
Sure.
interviews, guys, we will have some Q&A sessions also. So please keep on posting your comments, and also during the interviews, whatever positive, negative points which you feel that like if we made a mistake or if that point you thought that it's really awesome, then please keep on commenting that, and let's see how things go. All right. So Bhavya, let me share the Google Doc with you where we will start.
Sure.
It's over here, I guess. Let me share the screen. So is the doc visible to you?
Yeah, it is.
Awesome. So you might have heard of Fibonacci numbers, right?
Yeah.
Fibonacci numbers goes like this: f of I equal to f of I minus 1 plus f of I minus 2
Hmm.
for I greater than 1, and f of I is equal to I for 0 and 1, right?
Okay. Yeah.
Okay. So let's modify it a little bit. So currently, let's say we are saying f of 0 is equal to some random number a. We will give this in the input. And f of 1 is equal to some random number b. We will also give this in input. All right.
Hmm.
Uh, let's define a series S of I, which is basically summation of first I Fibonacci numbers. So f of 0 plus f of 1 plus f of 2 up till f of I. And let's define another series that is SSI, which is summation of first SI terms. S of 1 plus S of 2 plus up till S of I. So for any given input n, so given inputs will be A and B, which are the initial values of Fibonacci numbers, n and value n. We have
Hmm.
to find the value of SS of n. So is the question clear to you?
Yeah, I guess. Yeah.
Any doubts in the question? Anything which you feel like?
So, I'm assuming n is greater than or equal to 0 because that's what Fibonacci is defined for.
Yes, exactly. So n
Okay.
will always be a natural number.
Okay. And so, we know that Fibonacci series may go exponential, so the sum may also go exponential. So,
Yes,
how
absolutely
do we
right.
store that?
Very good. So in case we have bigger values of Fibonacci numbers and similarly S of I or S of I, we are taking mods. So let's define a mod like 10 is to the power 9 plus 7. So you have to return the value of S of n mod capital N. Let's say M is our mod.
Okay. So, a naive approach would be like to calculate all the Fibonacci series,
Mm-hmm.
uh, then calculate the prefix sum of the Fibonacci series,
Mm-hmm.
which will give us S, and then calculate another prefix sum, which
Mm-hmm.
will give us S of n.
All right.
So let's say if Fibonacci is x, y, the first two terms are a and b. So a,
Mm-hmm.
b,
Let's take some input. I mean, let's say A is equal to 1 and let's say B is equal to 1.
okay. So yeah, this is the standard Fibonacci series: 1, 1, 2, 3, 5, 8, 13. And
Right.
if we, yeah, we can go on calculating this. Then we will store the prefix sum, which will be 1, 3, uh, 1, 2, 4, and so on, 7.
Mm-hmm.
Then we can store another prefix sum, which will be 1, 3, 7, 14. And we will go on doing this till n, and we will find the, and we also will take mod so that there is no overflow,
Yes, correct.
and
Very
that
good.
will give us the nth number in the series s of s, ss.
Yes, right. Very good. Can we start with the code of that part first?
Okay, so I'm assuming the bounds on a are like 10 to power 5 or something, n are 10 to power 5 or something.
I mean, let's start and then later on we will discuss the complexity
Okay,
parts.
okay.
Just
So
assume you have a function in which you are given inputs A, B, and M. A,
okay,
B, and
so we
M.
have n, a, and b.
Yes. And we have to return nth S of n modulus
Hmm.
n.
So let's make three arrays: vector int f of size n,
Hmm.
s of size n, and ss of size n. We
Hmm.
know that f of 0 is a, f of 1 is b.
Hmm.
Also, we can like see that it follows the relation s of I is s of I minus 1 plus
Hmm.
f of I, because since it is the prefix sum.
Yes, correct.
Or actually we can store the prefix sum directly. So let's first calculate f.
Okay.
So for 2 to n,
Hmm.
f of I will be
Hmm.
f of I minus 1 plus f of I minus 2
Hmm.
mod. And since these are both less than 10 to power 9 plus 7, then the sum will at most be 2 into mod minus 2, which will be in the limits of integers. So there won't be any overflow issues.
Right, correct.
Now, s of 0 is f of 0,
Hmm.
and since we need to find prefix sum, so let's loop from 1 to n,
Hmm.
and we know that s of I is equal to s of I minus 1 plus f of I mod. uh, because s of I is the sum of first I numbers, and if we know the sum of first I minus 1 numbers, we can just take the ith number and add it to the first I minus 1 numbers to get the sum of first I numbers.
Yes, perfect. Nice.
Using a similar argument, we can do ss of 0 is s of 0,
Hmm.
and let's try to find ss of I similarly. This
Hmm.
will be ss of I plus s of I using the similar argument, and our answer actually we need to find the nth number, so let's loop till n,
Hmm.
and then we should return s of n.
Yes. So we'll just find it right.
Yeah,
Okay, very good. What is the time and space complexity of your program?
so we are looping over n thrice, so in the terms of big O it should be big O of n,
Hmm.
and we require arrays of size n as well, so space complexity will also be on.
Correct. So time is order of n and space is order of n, right?
Yeah.
Okay. Can we optimize like on the time or the space complexity?
Okay, so we see that Fibonacci only depends on the previous two numbers, and also the sum only depends on the last number. So we can
Hmm.
somehow store the previous two or one values
Hmm.
to eliminate this array.
Right.
So let's call f0
Hmm.
f uh, I1, which will denote the fi minus 1th number
Hmm.
initially, and fi2, which is fi minus 2. So initially, fi minus 2 should be a,
Hmm.
fi1 should be b.
Hmm.
So for 2 to n, let's calculate current f.
Hmm.
Current f will be the sum of f of 1 plus f of 2.
Hmm.
Let's calculate s and f simultaneously, s, ss, and f, because we are not storing anything. So s of I is x, ss of I,
Hmm.
actually it is for 2. So ss of 1 should be x plus y, because it's x, y, a plus b, sorry, a
Hmm.
and b, a plus b. And ss of I should be a, a plus b, 2a, 2a plus b.
Hmm.
Okay. So current is f1 plus f2.
Hmm.
Now let's date f1 and f2 as well. So now fi minus 1 will be current after this operation,
Hmm.
and f2 will be f of 1, because this was f2, this was f1, and now this is current. After the
Hmm.
next operation, this will become f2 and this will become f1. So f1 is current and f2 is equal to f1.
Hmm.
Now let's try to calculate s of I. So s of I should be s of I plus current f,
Hmm.
and ss of I should be ss of I plus s of I. And since we need to find nth number, we'll return ssi. So this should return the nth sum, nth term of the series s of s.
Okay. Hmm. Anything which you feel is can go wrong in this?
Okay. So our initial series is a, b, a plus b, 2a plus b.
Hmm.
This is our f, and s should be a plus b, 2 into a plus 2 into b, and so on. And then it should be a into a plus b. So I've initialized it correctly, and current will be the sum of fi minus 1 and fi minus 2.
Hmm.
Then f of I minus 1, since we are updating it for the next term, it should be current, and f of 2, fi minus 2 should be f of 1. Okay,
Hmm.
and the sum, so we should return s of I. Mhm. Logically, I don't see an issue.
One small mistake is there, and two small mistakes I can say. Just try and see.
Okay, so f of I minus 2 is a, f of I minus 1 is b, s of I is a plus b, 2
Just meanwhile, let me ask our audience. Audience, if you find anything which is fishy, please comment. Let's see.
This should be 2a plus b. Okay, so
Any help, any hint, let me know.
yeah,
So one of our viewers has given a hint that we should take modulo because the values may overflow.
okay,
So
yeah. So yeah, let's just take mod. This should be mod here.
hmm,
Another mod. And now let's just assume that all the operations we are doing are under this modulo.
okay,
Okay. So all the sum and multiplication are under this modulo. Mod 10 raised to 9 plus 7.
yes, right. One small mistake is still there, I can say. I mean, just try and see.
Okay, defining current F.
Hmm. And don't worry about the like capital and small cases. It's okay.
Yet Google Doc automatically does it. So
Yeah, it's okay. It's okay. One logical mistake is there. One small logical mistake. Just try and observe.
okay. So f of I minus 2 is A. This should be B. S of I should be A plus B.
Hmm.
S of I. So are the initialized values correct, right? S of I is 2A plus B. Hmm.
Any hints? Any help?
Sorry?
Any hints? Any help? Okay.
Yeah, yeah.
Okay. So one of our viewers has given a hint. Are you able to see that? Agardeep Das has given us a hint that F1 equal to current F should be above, like should be below F2 equal to F1. Reason is once you have updated current F, you are initializing current F to F1, and that current F is again added to F2. I mean F2 is also equal to current F now. Because of this, all the three parameters are equal. So we are
F.
keeping like using a track
No,
of
we
previous.
should keep it here. F equal to F. Uh,
Yes, correct.
F equal to F1. Yeah.
Very good.
Hmm.
One more small thing. I mean, please observe.
No, I think this is correct because this is the sum of previous two values, and initially it is not even initialized anything, so it will be random value.
Current F?
So I think the position of this is correct. This is the current value we are finding.
Yes, that is totally correct. Agree.
Mhm.
One small thing still. Okay, let's. Can you explain this code again once, and maybe then we can observe.
So F2 is the Fi minus 2 value, F1 is Fi minus 1 value, Si
Hmm.
is sum of like the second value. Okay, so we need the yeah 0 first value because we are calculating from 2 to n. So this is the second value we are calculating. This
Hmm.
should be A plus B, then 2a plus b. This is the initial value. Then this current f is the fi, which and also we are updating fi minus 2 to fi minus 1,
Hmm.
and fi minus 1 will be changed to fi because this is the value which we will use for the next term.
Right. Correct.
And then sum of I is the current sum plus the current f,
Correct.
and s of i will be the current sum plus S of I calculated till yet. So I don't
Hmm.
think.
One small thing. I mean, okay. If you observe, we mentioned in the start that n can be any value between 0 till large value. So we forgot
Hmm.
to take care of n equal to 0, I think.
Okay, yeah. So for n equal to 0, yeah, for n equal to 0, it will return a wrong answer. So for if n is 0,
Hmm.
we can return A.
Yes, perfect. Awesome. Now, what is our time complexity and space complexity?
So our time complexity should be On and space complexity should be O1.
Right. Is there any way to reduce time complexity? I mean, any thoughts on that?
Mm. So like Fibonacci numbers follow recurrence and we can find the nth number in O of log n using matrix exponentiation. So
Okay.
if we can find a similar recurrence for S of S, then we can also do it in log n.
Okay. Can you explain how we find n Fibonacci number in log n time?
Okay. Okay. So we know that Fibonacci numbers follow the recurrence f of I equal to f of I minus 1
Mm.
plus f of I minus 2.
Right.
So let's try to represent it in terms of matrices.
Mm.
So this is f of I, this is f of I minus 1,
Correct.
and let's try to represent it in terms of matrix with one difference. Okay, let's say this is a 2 cross 2 matrix which we will find now,
Mm.
and we are multiplying it by f of I minus 1
Mm.
and f of I minus 2.
Mm.
We should place such numbers here so that this relation is followed. So looking at the matrix relation, we can place 1 and 1 here because 1 into f of I minus 1 plus 1 into f of I minus 2 should yield f of I.
Right. Correct.
And we can place 1 and 0 here
Mm.
because 1 into f of I minus 1 is f of I minus 1 and we are then multiplying 0.
Makes sense.
Okay, so let's try to replace I by I minus 1
Mm.
in the above equation. So what it should yield f of I minus 1, f of I minus 2, and then the same thing
Mm.
f of I minus 2, f of I minus 3. Right? So let's replace this equation f of I minus, this is a vector matrix. So this is a matrix of dimension 2 cross 1.
Right.
Okay, let's replace this column vector here. So we will see that we get a relation. Let's copy this here. Uh, this square
Mm.
into, so this should be f of I. When we replace here, we get f of I minus 1 is equal to square of this matrix into f of I minus 2, f of I minus 3.
Yes. Makes sense.
Okay, so we see that this is I minus 2 and this is square. The sum of these numbers is I, and same here. So this is matrix raised to 1 and this is I minus 1. So I minus 1 plus 1, this sum is I.
Mm.
And we can again replace I by I minus 1 and go on doing that.
Mm.
So in general, we will get a relation that the sum is I. So for f of n, let's say replace I by n. So f of n minus 1,
Mm.
uh, then this matrix
Mm.
raised to a power. Let's find the power afterwards. And we know the initial two values f of 1 and f of 0.
Yes. Correct.
So what should be the power so that the sum is n, because we know that the sum is I here, so it should be n here. So we should raise to n minus 1. So this matrix 1 1 1 0
Hmm.
raised to n minus 1 into f of 1 f of 0. This relation should also follow.
Yes, makes sense.
Okay. So all we need to do is find a matrix raised to a power,
Correct.
and we can do it using exponentiation. So let's say we want to find, we know that we can multiply two matrices, square matrices of order n in n cube.
Right.
Okay. So, and this is since a matrix of 2 cross 2, we would require 8 operations, 2 cube operations. So let's try to find how we can raise a matrix to a power. So we can, so let's say if n is even, so n is even, we can write a raised to, we can write in terms of 2k if n is
Hmm.
even. So a
Hmm.
raised to 2k should be a
Hmm.
raised to k square, or a raised to k into a raised to k. Okay. So, and if it is odd,
Hmm.
then let's just write it as a into a raised to 2k.
Hmm.
So if we do it recursively, we will see that so if n is even, then we will find a raised to n by 2,
Hmm.
and we will store that value and multiply the value stored by the same. So if we know a raised to k, we can multiply it by a raised to k and
Hmm.
return that value. And if n is odd, then we can just multiply a and call a raised to 2k recursively. So we see that in the worst case, in every two operation, we will reduce n by 2. So if n is odd, then we will reduce it by 1, and if it is even, then we will divide it by 2. So if n is even, we will divide it by 2 in one operation, but if n is odd, we will subtract by 1 and then divide it by 2. So in the worst case, we are dividing it by 2 in two operations. So this will require 2 into log n operations to calculate a matrix power, like a matrix raised to a given power n.
Makes sense. Can we code this part where you are
Okay,
like finding matrix raised to the power n minus one?
sure. So let's assume that A is a global matrix 1 1 1 0, which we want to calculate,
Hmm.
and mult AB is a function which returns a matrix C, which is the multiplication of A and B.
Okay.
So let's, matrix is a class which contains the matrix. So matrix power matrix S comma int n. So if n is 0, we know that any matrix raised to 0 returns identity matrix. A raised to 0 equal to I, and identity matrix is 1 0 0 1.
All right. One question before we start. You mentioned A is a global matrix with one and 10, right?
Yeah, yeah.
So what is this S matrix?
So this we will pass it as a function. So we will
Okay.
pass matrix a comma n, and this
Okay.
will, okay. So this will
We
be
don't.
copied.
We can just say it's a matrix.
Yeah, yeah.
Okay.
So we will return I. I is again, let's say, global matrix 1 0 0 1.
Okay.
And if n is odd, n and 1, we can
Hmm.
return mult. So we will multiply a by power a. Actually, do we need? Actually, we don't need as, I guess, because if we are multiplying it, So mult A raised to n minus 1 power n minus 1. And if it is even,
mm,
then calculate mult
mm,
n by 2. So let's say it is a matrix B. Return mult B comma B.
What is this mult function? It's a mult is
It returns the multiplication of two matrices.
okay, but here we are not passing to matrix.
Oh, so sorry. This is power. So we will find a raised to n by 2 and then multiply it.
All right. Can we see a simple diagram like using, let's say, n equal to 6?
Okay, n equal to 6. So we need to calculate a raised to 6.
Mm,
So we will first call, since we see 6 is even, we will
mm,
call power a cube, power 3. And once
mm,
we to calculate a cube, we see that it is odd. So we will calculate a square,
mm,
right? Again, it is even, so we will
mm,
call a raised to 1.
mm,
Again, this is odd, so we'll calculate a raised to 0, which and we reach the base case, which is 0. So we'll return iota, identity matrix,
mm,
and then we'll like go up and above. So we'll multiply a by a raised to 0, and we will get a. Then we
mm,
will multiply a by a, and we'll get a square. Then we will multiply a square by a, and we will get a cube. Then we will square a cube, and we will get a raised to 6. Yeah, we will call this function mult bb.
mm. Nice. Correct. And as you explained, the time complexity will be order of log n, right?
Order of log n. Yeah.
Okay. So using this, like as you explained, based on the matrices, we will
Hmm.
be able to find f of n, like n Fibonacci term. Can we find s of n using the
Okay.
same series?
So, like, if we can find a similar recurrence for s of n, then we can find it.
Mm,
So, let's say we know this recurrence f of I equal to f of I minus 1 plus f
mm,
of I minus 2, and s of I is
mm,
f of I minus 1
mm,
plus f of I. So, we want a recurrence in s. Let's try to re- uh, express f in terms of s and then replace here. So, we
mm,
know that f of I should be s of I minus s of I minus 1,
mm,
right? So let's replace f of I here in this recurrence.
mm,
So f of I is s of I minus s of I minus 1, which should be equal to s of f of I minus 1, and f of I minus 1 is equal to s of I minus 1 minus s of I minus 2. Again, f of I minus 2 should be equal to s of I minus 2 minus s of I minus 3.
mm,
And let's try to recollect terms. So s of I should be uh, 2 into s of I minus 1,
mm.
and this will get cancelled, and minus s into s of I minus 3.
Yes,
So we
perfect.
found a relation for s, but
Mm,
we also need to find a relation for ss, and
mm,
so we can also s of s, we know that satisfies this relation. S of I is equal to ss of I minus 1 plus s of I.
mm,
So we can do similar thing like we did here and produce a series. So let's say call it 1, and s of I is equal to ssi minus ssi minus 1. So replace this in the equation 1.
This is equation one, right? Just so that you
Yeah,
don't definitely let me repeat.
yeah. So ss of I minus
Mm,
ss of I minus 1, this should
mm,
be equal to 2 into
mm,
ss of I minus 1, and ss of I minus 1 is equal to ss of I minus 1 minus ss of I minus 2.
mm,
Okay, and then we will subtract it by s of I minus 3. S of I minus 3 should be equal to ss of I minus 3
mm,
minus ss of I minus 4.
mm,
So let's try to collect terms to one side, and we will see that ss of I will be, so let's try to find the coefficient of ss of I minus 1. This should be equal to 2 plus 1 3, so 3 into ss of I minus 1. Try to find
mm,
the coefficient of I minus 2, and that should be minus 2, so minus 2 into s of I minus 2,
mm,
and let's try to find the coefficient of ss of I minus 3. uh, so ss of I minus 3 should be minus 1, s I minus 3, and I minus 4 should be plus 1, so ss of I minus 4. So we found this recurrence.
mm.
So let's try to do a similar thing as we did here, finding a matrix so that we can like find a relation raised to some power.
Mm.
Okay, so let's try to build a matrix for this. Mm, I guess I'm gonna use tables here too.
Mm.
Okay, so we'll need 1 6 plus. Hmm, so let's Popeye. Let's merge here.
Oh, nice.
Okay,
Yeah.
we don't need this actually, but yeah, that's fine.
Okay.
Mm, actually, we need one more row. Is it a method to add more rows?
This is our second equation, right? Like you mentioned.
Yeah, this is the final equation we want to represent in terms of a matrix.
Okay.
Mm, okay, so also let's merge this as well. Again, we will do the same thing. Represent s of I,
Mm.
ss I minus 1,
Mm.
ss I minus 2,
Mm.
ss I minus 3, and we will find it by difference of 1. So ss I minus 1, ss I minus 2,
Mm.
ss I minus 3, and this should be ss I minus 4.
If we observe the above one in the Fibonacci sequence, we
Mhm.
took two terms like f of I and f of n minus
Yeah,
1.
yeah.
Here we are taking 4. Can you explain why is that?
Sorry, can you
Can you
repeat?
explain why we are taking 4 terms over here and only 2 terms
Okay.
above?
So the basic difference is because that was a 2-degree recurrence. So it only depended on the last two terms, and here we can see that it depends on the last four terms. So to represent S of SSI, we
Mm.
need S of SSI minus 1, SSI minus 2, SSI minus 3, and SSI minus 4.
Yes, correct.
Okay, so we will. So it's a 4-degree recurrence. So we will require a matrix of 4 cross 4. So
Mm.
let's try to find the coefficients. So we know that SSI is equal to 3 into SSI minus 1
Mm.
minus 2 into SSI minus 2
Mm.
minus 1 into SSI minus 3
Mm.
plus 1 into SSI minus 4.
Yes, perfect. Correct.
And uh, we can represent SSI minus 1 using SSI minus 1 alone. So this should be 1, 0, 0, 0. So 1 into SSI minus 1. And
Mm.
similar for SSI minus 2 and SSI minus 3. So 0, 0, 1, 0. So SSI minus 3, and this should be 0 into SSI minus 1, 0 into SSI minus 2, 1 into SSI minus 3, and 0 into SSI minus 4.
Right.
So again, we can do a similar thing like we did in Fibonacci series. So we
Mm,
see that the sum, this is matrix raised to 1 and this is SSI minus 1. This sum is equal to I.
mm,
Okay, so let's just copy this. So this is a multiplication. Okay, okay. So let's write n here. This is n minus 1. This is n minus 2. This is n
mm,
minus 3. So the sum should be n, and we know that the base, we know the value 0, 1, 2, 3. We can find the value 0, 1, 2, 3.
mm.
Uh, so 1, 0, and we know that the sum is n. So this matrix should be raised to n minus 3.
Correct.
Okay, so this is n minus 3 multiplied by SS3210. So again, we can do a similar thing like we did here. So we'll call power, but instead now this matrix, global matrix A, should be this matrix 3 minus 2 minus 1 1. And again,
Mm,
yeah, like since we are calculating it modulo given number mod, so we
mm,
will, whenever we multiply two matrices, we will like do it modulo mod operation. So here also, since these are negative numbers, we will add mod here. So minus 2 plus mod and minus 1 plus mod in order to like do it modulo given number.
yes. Perfect. Can we write the code of that part where we are given an input and we are finding these values? You can assume you have this power function,
Yeah, okay,
and you can assume you have the matrix multiplication function in
okay.
which you are multiplying the matrix.
So again int, so uh, ss
Mm,
int and int a and b, which are the initial values, right?
yes. Perfect.
So we should use the first four values. This
Mm,
should be a plus b. So let's write here. We need the first four values as base cases, right? Like we need to, whenever we get a matrix, we'll multiply it by these four values. So
mm,
a, b, a plus b, and a plus 2b,
mm.
2 into b. This should be f, and
Basically, this.
s. Yeah,
Mm,
this is f. S will be a, b, a plus b,
mm,
2a plus 2b,
mm,
and then 3a plus 4b.
mm,
To this, we are adding 2a plus 2b by a plus 2b, so 3a plus 4b. Again, we'll find the prefix sum of s to get ss, and this should be a 2a plus b, and
mm,
we'll add 2a plus b by 2a plus 2b, so it should be 4a plus 3b, 4
mm,
into a plus 3 into b, and then we'll add 4a plus 3b by 3a plus 4b, so it should be 7a
mm,
plus 7b. So let's initialize these values here. A 2a plus b, 4 into a plus 3 into b,
mm,
7 into a plus 7 into b.
mm,
Okay, so uh, this is our matrix. Mm, A,
mm.
B is f n minus 3, because we need to find the power n minus 3 in this case. Okay, and to get the nth number, so we need the value at the first row. So this should be like if we've got this matrix, this should be a00 into ssi minus 1 plus a01 into ssi minus 2, like sorry, a00 into ss of 3, a01 into ss of 2. So let's loop from 0 to 4. So this is answer, int answer equal to 0, for int I equal to 0 to 3, 4 actually,
Mhm.
I plus plus. So
Mhm.
answer will be bi. So b, we will only need the like first row. So b 0 I into ss of 3 minus I, because we are multiplying b00 by ss of 3, b01 by ss of 2, and b03 by ss of 0. So the sum is 3. So I and 3 minus I. And
Mhm.
again we will do all these operations modulo mod. So okay, let's do it here. So since we are using integers, so it multiplication of two numbers which are greater than, which are like about of the order 10 raised to 9 will be of the order 10 raised to 18, which is outside the int limit. So we will write 1 ll here. So it will change this number to long long, and there won't be any precision like overflow issues. So this is this modulo mod, and again answer modulo equal mod. So we'll return mod. Oh, sorry,
Mhm.
answer.
So is it fine from your end?
Sorry.
Is it final from your end? Do you like to recheck it once? Maybe.
Okay. So
Mhm.
again, like we may have missed some base cases like we did previously. So let's check if, like if n is so we have not the function is not defined for n negative, the f power function. So this is not f function, this is power function, and this is
Mhm.
not defined for n negative. So if n is less than 3, then like there is an issue with this code.
Mhm.
So so if n is less than 3, we can use the pre-stored values.
Correct.
Okay, so if n is less than equal to yeah, equal to 3, we can include it or not, it doesn't matter, because we have both here, and this will return iota. So this should be return ssn.
Correct. Very good. One thing more I would like to suggest. I mean, can you see one more mistake? Is there one small mistake?
Okay, again, yeah, so here we have to include mod as well.
Yes.
And so we may have to include 1 ll here as well, because
Mhm.
10 raised to 9, like the limit of int is 2 into 10 raised to 9, something about that. So this may cause overflow here. 1 ll, here as well. Yeah.
Mm, one typo. I can correct this part. Okay, one question. Is it necessary to write 1 ll, or can we just write 2 ll and 4 ll?
Yeah, yeah, we can write that.
All right, no worries. Perfect. So what is the time complexity and set complexity now after the final solution?
So it should be we are multiplying two matrices in 4 cube. So it should be
Hmm.
4 cube, and we will only require log n multiplications,
Hmm.
or 2 log n actually. So
Hmm.
4 cube into 2 log n. It is order of log n approximately.
Yes.
So like if the matrix was of size k cross k, then it should be k cube log n. So in that case, this k cube term may be like more dominant in time complexity.
But in our
But here,
case, K.
but in our case, it is 4.
It's perfect. What is the space complexity?
Uh, so we are only storing matrices here.
Hmm.
So it should be O1, but yeah, for calculating the power, we are using recursion. So we are pushing the like all the matrices on the stack, so that should be log n. Although we can write iterative power as well, function as well. So that will reduce the space complexity to O1.
Hmm. Right, correct. But the recursive part is login, right?
Yeah, yeah.
Okay, perfect. And I think the solution is also very nice, very good. And we are done with our 45 minutes interview, I guess.
Okay,
Awesome.
thank you.
Good work, Bhavya. Really, really nice going. So, few feedback. I mean, all the viewers, please note, I mean, few things which matter in the interview really, really much. First, I mean, very positive point was that he was able to solve the complete solution. He reached the final login time complexity. That is a really big plus point. Few small mistakes which can be improved are, I think, the formatting issues. We should have spaces between the operators and separators, little formatting, but that's okay, not a big deal. And I think rest everything was really, really awesome. So let's see the comments. Let's see what our viewers have posted. Don't see much. Bobby, how was your experience? I mean,
So yeah, it was really exciting when I was a bit nervous. Like sometimes when I wasn't able to find like small mistakes, and yeah, it's been a long time since I've like faced an interview. So yeah, it was both nervous and exciting as well.
yes. I mean, again, like
Uh,
I agree that it's the first time and that too live interview, so it's obvious
yeah,
that you are nervous.
yeah, it's a new experience for me.
Okay, nice. And did you like the question?
Yeah, it was a good question. So, like a twist in the standard Fibonacci question.
Thank
So
you.
yeah, the key was to like get the recurrence, and then I think it was really easy because I was aware with matrix exponentiation actually.
Hmm.
Mhm.
I guess meta explanation for Fibonacci is quite famous one.
Yeah, yeah. I mean, it's difficult to get a solution from scratch if you are not aware with the technique.
Hmm.
Hmm.
Agree, totally agree. All right, guys. Any questions from your end to Bhavya? Open questions. Any questions you would like to answer them? Vivek asks, is he able to clear the round? Yes, because he all the complete question with the expected time space complexity. So totally.
Someone is unable to reduce the complexity in the interview. What should be done?
Bhavya, what your views on this?
I mean, so like you're expected to do that. So try to explain your brute force solution first, and then try to like the interviewer always gives you help like hints as well. So if I wasn't able to come up with matrix exponentiation, so Utkarsh would have helped me like to get it to like log in complexity. So he would tell me if you he would tell me about divide and conquer, like not divide and conquer, so dividing the power into two and representing the uh, recurrence into matrices. So yeah, try to explain your brute force solution. So mostly interviewers like check your thought process, and if you're near to the solution, they will guide you to the solution.
Hmm, perfect. And one small tip is there, like if you are stuck and you're not able to reduce the time complexity, then try to take small examples and try to do a dry run on them, and you will see some patterns or observations that can
Yeah,
help you reduce the complexity. That helped me a lot.
yeah, yeah,
Okay.
true.
One from Akhil, we have how to start preparation for ICPC. That is very famous and obvious question.
Okay,
So, being a world
so
finalist, your tips are really helpful here.
I would say like I started in around second year my sixth preparation.
Hmm.
So we did a lot of team contests, and like first you should brush up some of the topics like IC like ICPC topics generally. So in most of the cases we don't even know the topics. So like there are topics like max flow and then fast Fourier transform, which are somewhat asked you can solve the first 5 4 problems without having much knowledge, but after that you would require some knowledge about standard algorithms and data structures. So yeah, first try to brush up on some topics, then like do as much practice as you can, like do team practice as well. So what we did do in team contest is that we find our strengths. So like if my strength is like kind of mathematics, so I was lucky as well, so to get a mathematics question. So and like my other teammates may be strong in graph, so find a team diverse set of teams. So like you would have different skill set in your team.
Hmm.
And yeah, mostly like I would prefer practicing on the online judges. And even if you are solving a contest, try to absolve it. So most people like don't solve, like they only solve try to solve problems during the contest but not after that. So that's not really much helpful. Try to see the editorial and try to implement it on your own.
Hmm. I mean, that tip is really helpful. That please try to find a team which has like diversity, so that it's not like all the members are strong in maths and no one is strong in graphs. And also, team practice is really important. Let's take one more from Anmol. What is the toughest section you have faced in any interview? Bhavya,
So I'm
any
not sure what he means by section.
maybe your toughest experience in interview? I think he meant that. Any
Okay,
interview was very tough for you?
uh, so like I wasn't really acquainted in my third year and sorry second year starting, and we had some internship tests and interviews. So that was a bit tough for me. So mostly like if you are applying for finance firms, they ask you good puzzles. So I was stuck in some of them, and I actually he helped me through solving them as well. So it was a good experience and but tough as well. I don't
Hmm.
think we could. I could. It's a big puzzle, so I don't think I could share it right now. But it
Okay,
was a
no
good
worries.
puzzle. Uh,
Well, I can share my toughest interview. That was one of the Google's on-site rounds, where the interviewer asked me about probability. That is
okay.
with most of the guys. So it was a really tough probability question, and I was not able to reach the final optimal solution. So this
Okay.
also answers one of these questions. We have,
Is
mm,
this level of math?
yeah, this question from Akshay that if previous, then this question is optimized by previous known techniques. If anyone doesn't know, then will the candidate be passed or not? So Akshay, in my scenarios, I was able to not solve it completely, that probability question in the whole Google onsite, but the rest 3 rounds were really awesome. So out of 4 rounds, like you are just based on all the 4 rounds, not just one round. So if one round is not very well or very awesome, and other three are really awesome, I think you can be selected.
Mhm. So like
On.
they don't ask the similar uh, questions from fixed topics. So they ask questions from diverse topics. So
Hmm.
you're expected to know at least some of them.
Yes.
Mhm.
I mean, maths is a really important topic. And we have one question from Akshay that how to prepare for maths. So Bobby, I think you are really good in math.
I mean, again, the same thing, yeah. So like I practice on online platforms like Codeforces and some like I also try Codechef long challenges. They have some good mathematics problems. And if you want to like read something maths online, I think CP algorithms is a really good like resource to study. You can find amazing blogs and
Yes, and I think Project Euler is also there for maths if you want to start watching.
project. I didn't try project earlier, but I won't recommend that as well. So they don't have like they have mostly like number theory problems, and that requires some lemmas. If the hard problems are generally not really helpful, so you can try the medium ones, but mostly the hard problems I've seen they mostly use some lemmas which won't help much.
Okay.
Will you post the entire?
Few more questions. Any more question, guys? Say yes, the video will be available. So Shivam says how many years you have prepared for ICPC. So Bobby, when did you start your programming? I mean, in which year?
So we had an introduction to C course in first year, but I wasn't doing like competitive programming on online judges. So I started it in like second year. I was doing it. So I started with long challenges in Codechef and then moved to all the various platforms like Codeforces and all. Like short, I started with long challenges and then as my speed increased, I moved to short challenges as well. And side by side reading topics on various platforms. So I don't think there is any less like there are a lot of learning resources you can find. All you need is like you can just Google the topic and you will probably find tons of resources. And I like first time I qualified for regionals was in second year. So
Nice.
and yeah, so we went to second year and we didn't perform really well in the online we did well in the online qualifier round, but we didn't do good in the on-site. And then I changed my team in fourth year. So and this year we were luckily able to get it to world finals.
What is the difference you think between second year and fourth year? I mean, obviously your experience of 2 years, but apart from that,
Uh, so like I had
any-
a different team as well, so there were different, I think, skill set as well, and yeah, exactly experience as well, and maybe luck as well. So you have to be a bit lucky as well. Like you get problems which of topics you are strong at or something.
hmm, right, right. All right, guys. I think we have
We
answered.
actually had a really fun, like we were really lucky as well this year. So in the online qualifier round, so there were
Hmm,
seven problems as far as I can remember, and we
hmm,
solved six of them. And the last problem was really like HKC one. So we need to handle a lot of cases and all, and it was a 3 hours. So like couldn't able to we weren't like we were writing the code, but we were getting wrong answer. So at during the end of the contest, we submitted the seventh question. We didn't know what was the result till the end of the round. So like the
yeah,
contest was finished, but we didn't know whether it got a AC or like wrong answer. Then so I don't know Codechef, like they have a really long queues. So
hmm,
after around 3 minutes, we got AC and we were like really happy because we solved all the problems and like we weren't we it was very like surprising that it got AC finally.
congratulations. That's really,
Yeah.
really.
Like in the last minute, we were really happy that it got accepted.
I think let's take one last question. One last question. Let's see. Hmm, hmm. Some language. All right. This one I can say. What programming language can you work with? Describe your experience with them. So, Bhavya,
Hmm.
I mean, how many
So,
programming languages are you comfortable in?
so I'm comfortable with C++, and so like if you are talking about competitive programming, generally prefer people prefer C++.
Hmm,
Apart from that, like I'm familiar with Python for I've done some machine learning projects, and then like you can just learn it on the go. So I've learned Angular JS for internships and Java for like some project as well. Like I'm familiar with some of the like not very I've not very good expertise with most of them.
hmm.
So like mostly you can in software engineering you can learn it on the go, I guess, because we are using different tools and technologies every day, and in that case it's not like you will be working on a fixed technology for a long period of time.
Agreed. All right. Awesome. So I hope it was a great
If you are
experience.
talking about like competitive programming, I would say like I would prefer C++ because it has a standard template library, which is like you can write your code faster, and it's also fast. Other like unlike other languages, it's probably the fastest, and like most platforms and even ICPC don't guarantee that your solution will work with other languages like Python, but in C++ it is guaranteed that it will work.
Hmm. I usually do CP in Java, by the way.
Okay.
So,
Yeah, in Java actually, yeah, in Java is also fine, but
hmm.
don't use any interpreter language actually. So interpreter language generally, yeah.
Yeah, they are really slow and it can get time limit. You use optimized solutions. Yes, totally agree. All right. So shall we end this? Guys,
Yeah,
thank
yeah.
you very much for watching. And if you like it, please like the video, share and subscribe. And if we have good number of likes and subscriptions, then we will come up with another great competitive programmer of the country, and we will try to have another like live mock interview probably next week. So please do live and subscribe to the channel, and also the bell icon so that you can listen to the notifications. Thank you guys, and bye bye. Thank you, Bhavya.
Thank you for having me.
Bye,
Okay.
guys.